When analyzing the runtime of an algorithm, when we have a recursive function, we come up with a recurrence instead of a runtime function. So here I have an example of a recursive function which sums from the numbers a to b. So in this case I'm going to consider n, namely the input size, to be b minus a. Okay, since I'm trying to sum the numbers from a to b, how many numbers are there between a and b? Is b minus a. So that is going to be my size. Then I'm basically saying if a is greater than b, I want to return 0. If they're the same, I'm summing from a to a, which is a itself. Otherwise, I'm going to cut it in half. So I'm going to say a is the sum from a to b over 2. And I'm assuming that this is a Java-like structure, so b over 2 will take the floor of b over 2. And if and y is going to be the sum from the second half, b over 2 plus 1 to b. And what I want to do is return x plus y. Because when I want to come up with a recurrence, I really do a direct translation. So my input size is n. So a recurrence I usually express as t of n. And what is this equal to? Well, when I have a recursive function, I have some recursive calls. So I'm going to look at those first. So here is one recursive call. What is the runtime of that? Well, just as a recursive function, I'm going to express this recursively. The runtime of that is also t, but what is the input size here? Well, I've cut the input size in half by taking b over 2. So I basically said I'm taking half the size and doing a recursive function for that. And that is the runtime. So I've taken care of this line now. This one is done. Then there's another recursive call, which also takes half. So a recursive call, the runtime cost is some function of t. And I have to look at the input size, and here I have the other half. Again, I'm saying n over 2. And notice that I'm assuming here that this is an even number, that b will always be an even number. If I don't, I have to deal with floors and ceilings. I'm going to ignore that for now. So this has taken care of these 2 lines of code. Now I have 3 other lines of code, and here I'm just going to do counting. So I have a comparison, I have another comparison, and I have a return statement. So about maybe 3 or 4 or 2 statements, so some constant number. So plus c, where c is some constant. And when am I doing this? When am I doing these recursive calls? If I have at least 2 numbers in this case, because if I have only one number, namely from if the size, if n is so if n is 0, I will not do any recursive calls. If n is 1, I will do recursive calls. So this is the case if n is greater than or equal to 1. If it isn't, if it is 0 or less than 0, then this here is equal to some other constant, d, if n is less than 1. And again, where d is some constant. And that's it. This is my recurrence. So mapping a recurrence with, or mapping a recursive function to a recurrence is a direct translation. I take my recursive calls and make that a recursive definition, and then I add everything else up together to be placed over here. And that could be cost n, it could be any kind of a cost, but in this case it is constant. So this is coming up with a recurrence for a recursive function.